All right, after a morning and early afternoon of a lot of stuff about policy and things, it's time for a technical talk in Party Track. And we're going to hear about a new tool and a new service that is going to be exciting. And once again, we have a first-time attendee and a first-time speaker. So, and Elijah's totally calm, not worried about it at all. What's that? Eijah. I apologize. Eijah. And he is thrilled to talk to you guys about his tool that he's been working on for a long time, talking about Demon Saw. So let's give him a big Party Track welcome.
Thank you. Recently, our right to share files online has been under assault by governments, corporations, and others who fear openness and personal privacy rights. People have been persecuted, fined, and even imprisoned simply for sharing data electronically. As private conversations transition from the home to the web, we're losing our fundamental rights to privacy and personal beliefs. Imagine for a moment a secure file sharing application that lets you share whatever you wanted with anybody you wanted across all of your devices without fear. Governments, corporations, and others would not be able to know what you're doing, what you're sharing, or know who you are. They wouldn't be able to track your IP address, and not being a centralized based network, they could not take you down. Now, imagine 1 million file sharing networks just like that. This presentation is a free data manifesto, a historical analysis, and a recipe for creating a new type of file sharing application. My name is Eijah, and I believe in the right to share. Glenn Greenwald said, "One can easily remain free of even the most intense political oppression simply by placing one's faith and trust in institutions of authority." But I think the Bible says it even better in Psalms 56:3. "When I am afraid, I put my trust in you." The modern internet is a very different place today than it was in the past. We can define the modern internet by 4 different states. It's a state of trust, a state of convenience, a state of control, and a state of change. Over the last 15 years, the internet has shifted from a web of isolated content to a cloud of interoperable networks and trusted third parties. A primary reason for this state of trust is technological innovation.
Speaking of a change. Continue.
Shot time. So companies have begun to support open source technologies, web and data standards, shared protocols, and interoperability. This has been going on for the last 15 plus years, but it's more prevalent now than it ever was before. Interoperability being the mutual trusting and coexisting of disparate domains, like single sign-on, shared authentication protocols, and OpenID, which is what we use when we log in with our Facebook accounts.
Okay, now we're ready.
All right, let's do this.
All right. So, you all know the drill. By the way, I wasn't going to interrupt a Bible verse walking in here. I had to pause for a second. I'm like, oh shit, maybe I better. Anyway, it is very hard to get selected at DEF CON. Congratulations.
Thank you.
Welcome to the team.
Thank you, guys. All right.
As you were.
Thank you, sir. So the benefits of trust are cost-effective applications. Companies can roll out applications faster than ever before. It's faster to get their applications on the market. It's easier to share content cross-domain. Different companies are working together that never did 10 or 15 years before. And there's a level of convenience to us as users of this content. Now, trust has made possible a level of convenience that we have grown accustomed to and can no longer live without. We have improved application usability, like signing in with our Google or Facebook accounts everywhere. There's everything at our fingertips. All of our content, our bank accounts, our social networks, everything we can get to from our laptops, our home computers, our phones, our tablets. And everything is simple now. There's obviously concerns with this, such as our privacy, our anonymity, potential for abuse from these companies, and an overall loss of control. For a model based on trust, the cost of convenience is control. When our personal data is in the hands of others, we've lost control. At that point, we're faced with some rather difficult questions. Who owns our data? Are we simply a source, or are we greater than the sum? A fundamental flaw in the model of trust is this loss of control. And once we've given up control, it's gone forever. My favorite examples of a loss of control and never being able to get it back are, I have three of them. One is the release of the AACS processing and device keys and the continual release of those. Number two is, and I still find this absolutely fabulous, is the Tom Cruise Scientology videos. If you haven't seen those, I highly advise them. It's 7 minutes well worth to watch those. And of course, WikiLeaks and the great work that they're doing with releasing documents. Loss of control brings concerns to us as private citizens. Data retention and oversight. Do we trust the companies to take care of our data? Legal compliance matters. What corporations are giving our data over to the governments, and what are the governments doing with that data? Security breaches and what happens with our data when companies cannot protect what's ours. And overall transparency. Do we have the right to know that what companies are doing with our data behind the scenes? And finally, the bottom line, because everything a company does, it's for its own best interest and is driven by financial means. The truth about this modern internet is that convenience does not require trust. We can achieve the same level of convenience that we get today without giving up control and without trusting governments and companies. The power to change the world is in our hands. We're experts in our fields. We're passionate, envied, and feared. We have the knowledge, tools, and experiences, and most importantly, we have the free time to code. The path forward involves becoming advocates for distrust. Even Ronald Reagan, I know I quoted the Bible, now I'm going to quote a Republican. Even Ronald Reagan said, "Trust but verify." We can break the mold of old and stale thinking. We can create something beautiful and secure, and we can open up the internet for what I call digital self-expression. Stephen Hawking said, "The increase of disorder or entropy is what distinguishes the past from the future, giving a direction to time." And Aaron Swartz said, "Information is power, but like all power, there are those who want to keep it for themselves." Reinventing file sharing means that we need to understand the current file sharing applications available to us now. We also need to understand how secure or insecure these applications are. So let's look back in history and let's take a look at the existing file sharing applications to see what type of model, network model they're based on. There's two primary models for file sharing applications: the centralized model and the decentralized model. The centralized model is a tried and true model with over 45 years of history. Did you know that FTP is over 45 years old? I did not know that until I did a little bit of research for this presentation. That is amazing. The pros of the centralized model are fairly obvious. It's a simplified programming model. If you've taken any computer science classes or you get bored at home and code like I do, you know how simple it is just to open up a socket connection and send some sort of data. It's a very, very simplified programming model. There's dedicated hosting benefits for a centralized application. Web hosting now only costs a fraction of what it did 5, 10, 15 years ago. You can get a shared hosting environment in Linux or .NET for $3 a month. That is extremely inexpensive. The cons are logging and auditability. There's a lot of credential-based security with the centralized model. Companies are storing our information. There's the question of digital rights management, identity or IP and usage transparency. And the centralized model is easily susceptible to takedown. It's a single point of failure, and it's very, very easy for governments or corporations or the legal system to go after a single point. Here are some examples of different type of file sharing applications that use the centralized model. Most of these will be familiar to us. We have file system based like Samba or NTFS. We've got IRC, FTP. We've got some web-based choices like Mega, RapidShare. We've got some new streaming applications like Netflix, Prime, Go, etc. And we've got cloud computing, which entered the market a few years back, like Google Drive, Amazon Web Services, Dropbox, etc. The decentralized model, on the other hand, is a rather newer model for file sharing, but imperfect as well. The pros are there's no central point of access or failure. It can also last forever. A well-designed decentralized file sharing application or network, once live, has the potential to never be taken down. However, there are some concerns with the decentralized model as well, such as identity and IP usage transparency. That's the same con as we saw in the centralized model, and we'll talk about that later on. You also have the loss of anonymity. Your IP address is revealed, and that can be linked to your name. There is personal liability, which is something new. The legal system can go after us directly for downloading files via BitTorrent. And then there's a security issue too. Really quick, I just want to point out some of these. These should be all familiar to you, but BitTorrent, to go way back, Napster, the start of it all, stuff like Plex, rsync, or Plex is newer to the market, and then of course some streaming applications that I think are very exciting, like Chromecast and of course XBMC, which has been around for a long time now. File sharing is an amazing technology, but this doesn't mean that it's perfect. There are some fundamental problems with file sharing. For example, file sharing is insecure. Either we trust a third-party source, like a centralized server or a set of applications, or we risk revealing our identity via a peer-to-peer or a decentralized network. There's also legality issues with file sharing. It's also inflexible. I want my files available to me at all times. I don't want to force sync content across my devices. And what if I'm offline? If I'm offline, I can't stream Netflix, or I can't grab my files via Dropbox. So I want more flexibility in file sharing. It's also inconvenient. I want to watch the show that I'm paying for. I don't want to watch ads. Probably the thing that most upset me about Hulu Plus is the requirement that we watch ads. Some of them are funny, but seeing the same ad 4 times over in an hour is not funny anymore. Why do we have to watch ads? File sharing is also unreliable. If you look at streaming providers, they have exclusive content and they have licensing disputes, which changes the content available on their sites. Netflix, Prime does this all the time. Network outages. Why, when they go down, should I suffer? And there's not enough seeds for BitTorrent. I want something that nobody else wants. How do I get that? File sharing choices are sometimes expensive. Has anyone looked into upgrading their Dropbox accounts? The free 2 gigs that we're given cost substantially more when you want 100 gigs. That shouldn't be the case. Hard drives are cheap these days. The cloud is also expensive. And not only the price, but what do these companies do with our data? Who has access to that? And then what if it's stolen? Netflix and Amazon Prime, I think, are doing it the best. HBO Go, not so much. I don't want cable or satellite. My HBO subscription is through uTorrent. Some of my friends get their HBO subscriptions through the HBO subscriptions of their friends and their logins. I would prefer to watch HBO through Netflix or Amazon Prime. Now granted, HBO finally caved in recently if you want to watch shows that are 5 years old. What about the shows that are out now? So my Game of Thrones subscription is through uTorrent. The modern internet has also taught us to value something if it is good, convenient, and reasonably priced. So I want to just throw those 3 things out there again. The modern internet teaches us that convenience is a good thing, and we like convenience. But it's also taught us to value things that are good, convenient, and reasonably priced. This is why we still torrent. This is why we still download illegally. I find, for my personal use, that if it shows on Netflix or Prime, I'm much more likely just to stream it because it's good, convenient, and reasonably priced. And it's actually more work to torrent it. And finally, file sharing problems. File sharing can be unfair. Not all usage patterns are the same. The BitTorrent network is a very important and a very powerful network, and we probably all use it. But it's designed to adhere to a state of pseudo-equality across the board. If it didn't, then we wouldn't be able to download if we didn't have to upload. So the ratio of seeding to downloading is very, very critical. But not all usage patterns are the same. What if I only wanted to download? Is that possible? Well, it should be allowed. The differentiation between acquisition, which is the initial acquiring of new content, and the subsequent aggregation of that, which is the dispersing and sharing, should be separate models in a file sharing app and configurable separately. So these problems with file sharing have led to the creation of a niche market for solutions. Inadequacy breeds innovation. VPNs, proxies, firewalls, darknet, Tor, PeerBlock, which doesn't work, but people like it nonetheless, and hacking our neighbors' access points are all cures to the symptoms and not the problems. You laugh, but many of us do it. I probably shouldn't admit that I would do such a thing, but if I did, I would laugh as well. Yes, exactly. So reinventing file sharing. We need to, in order to reinvent file sharing, we need to leverage the power of our internet access. I'm going to quote Aaron Swartz. He said something absolutely amazing in 2007. He said, when you have a distributed network like the internet, everybody can be a server. You can take your home laptop and run a server off of it that can distribute movies and music and web pages and email in the same way that the biggest computers at Google can. There's no fundamental difference between the computers they have in the racks in their server rooms and what you have on your desk. He was absolutely correct. Reinventing file sharing means that we need a new solution that's secure, anonymous, free, and everywhere. So what does it take to reinvent file sharing? Noam Chomsky said, if you want to achieve something, you build the basis for it. And Julian Assange said, the only way to keep a secret is to never have one. So let's talk about 5 key principles that will secure file sharing network and maintain the privacy of our data. Number 1, saving cyberspace means that we need to reclaim the authoritative source. Well, what is the authoritative source? The authoritative source is the primary repository of trusted data. It's basically our data that we're about to share. When we give away the authoritative source, we give away the control of our sensitive data. And the price of online data storage is our anonymity and the potential for the abuse of our data. So the foundation of file sharing is data, right? Everything is based around data. And data should be the first thing secured and the last thing to be compromised. It should never leave our control. Companies, I used to work in the financial sector, and companies, I learned, are very, very good at securing their devices. Their corporate devices like laptops and phones and USB drives, they excel at securing those. But they're very bad at securing network transmissions and between those devices. The weakest link are the users and the methods by which they exchange data. When we lose control of our data, we lose control of everything. This includes the power to protect what's ours, the certainty that our data is protected, the choice to respond to attacks, and the ability to remain anonymous. The solution? We need to take responsibility and reclaim the authoritative source. Our data should not leave our personal devices. It should never go into the cloud. It should never go into Dropbox. It should never go beyond the devices that we own, like this laptop or my phone or my tablet. We need to do what companies continue to fail at, and that is secure our data. Number 2, saving cyberspace means that we need to redefine authentication. Well, what does it mean to authenticate? We do that all the time, multiple times per day. Simply, authentication is the process by which I prove who I claim to be. That's really it. Right now, there are many, many forms of stateful authentication. Stateful authentication is usually credential-based or certificate-based authentication where there is some sort of state that's maintained, usually in a database. It's a necessary model, but in some cases it can be antiquated and unnecessary. Relying on trusted third parties is not always the best solution for authentication. Stateless authentication is a form of shared secret authentication that leverages shared assets or other known data to mutually authenticate clients. The benefits are obvious in that the modern internet gives us a wealth of information or shared secrets, such as pictures that we've uploaded to Facebook, or posts that we've made, or tweets, etc. There's an immense amount of information available that can be used as shared secrets across multiple people. Mutual coexistence by shared knowledge is the basis for stateless authentication. This means that the shared secret is something that's obvious to a very specific group of people. There's no registration process and no data storage. No need for databases, SQL or otherwise. And the beauty of this is we can use a series of dynamic encryption algorithms based on this information because no state needs to be maintained. So there's no certificate authorities, there's no databases, there's nothing in the background that can link what we're doing to our identity. So the solution for stateless authentication is redefine what it means to authenticate. Let's create a temporary trust. We've learned that trust is bad, and we should be advocates for distrust. But temporary trust that can be changed and modified over the course of seconds or minutes or hours is valuable. Our social networks have an immense amount of shared secrets that we can tap into. No data is stored, and the loss of security becomes insignificant with stateless authentication. Why? Because it's not necessarily a security model that needs to stand the test of time. It's a transitory nature of stateless authentication that has the ability to adapt via dynamic encryption algorithms. Number 3 is saving cyberspace means that we need to implement a modular approach to security. Modular security is something that is based on layered security. Layered security being the practice of combining multiple mitigating security controls to protect data, make it more difficult to compromise the whole. Well, modular security takes layered security and builds on top of it by creating more of an obfuscated and a disjointed separation of duties. Uses a double-blind approach so nobody knows the entire secret, and there's an inability to store complete secrets. It's not feasible in a network design based on modular security to have any secrets. In fact, it's a bit like a free-for-all. It's kind of like a Hail Mary in a way, but it's a guaranteed touchdown, so perhaps that's a bad analogy. The existing applications today are too tempting targets for takedown. There are too many single points of failure. They reveal too much information. Modular security provides plausible deniability. We should always assume that somebody is listening. Always be paranoid. It's better to be paranoid than to be caught. And what they don't know won't hurt us. They cannot audit what we do not have. The solution: implement multiple modules of defense to resist penetration. As messages propagate through the transmission stream, they will increase in strength. But nobody will be able to know the entire secret. And even a compromise of 99% of the network will not reveal the entire secret. Each module, therefore, is isolated, autonomous, self-sufficient, and resistant to attacks. Number 4, saving cyberspace means that we need to leverage existing protocols. Our choice of protocol, message or otherwise, does not define us as an application. When we create a new file sharing app, it's really about art and science. This is my second file sharing app now in the last 15 years that I've created, and it truly is always a journey. This one I'm about to share with you shortly has taken a year part-time as a labor of love. But creating a message protocol is true wizardry and much more difficult than creating a file sharing app. So use standard protocols. The benefits are obfuscation, which there's a Japanese proverb that I love that says, "The nail that sticks out gets hammered down." What this means is calling undue attention to ourselves will only result in problems. So let's blend in with the rest of the HTTP network traffic. Pretend like we're no different. It's interoperable. It will work with existing web services and websites, and hopefully will arrive at undetectable transfers. The solution, keep a low profile, use these pre-existing protocols, stuff like HTTP, XML, JSON, etc. And finally, number 5, is saving cyberspace means that we need to support a more flexible and adaptive model for file sharing. What does this mean, flexible and adaptive? Well, first of all, we need to be simple and effective. It needs to be easy to use our file sharing app. BitTorrent is an amazing protocol, and uTorrent is an amazing application. I use uTorrent almost every day. It's very complex, and a lot of my friends aren't necessarily, they're not like us. They might not have the same technical background. So if we can make something that everybody can use, then file sharing can be everywhere. Individuals, families, and organizations, small, medium, and large, should be able to use this application equally. It should be available on all of our devices: phones, tablets, workstations, laptops, servers, and even low power consumption devices like the Raspberry Pi and the Ouya, or even these badges, should be able to run file sharing networks. It's very, very possible. Also, operating systems should be operating system agnostic. Windows, Linux, Mac, Android, and iOS, it should support all of them. And finally, we need a hybrid model. We need a file sharing app that takes the best of the centralized model and the best of the decentralized model and removes everything else that's crap. How do we create this hybrid model? We need to abstract the content from the transfer. No fixed servers and no direct peer-to-peer. So nobody knows about your IP address and no fixed servers. It needs to be pervasive and ubiquitous. What's that mean? It needs to be everywhere and throughout everything. And it needs to be secure, anonymous, free, and everywhere. Edward Snowden recently said, "I don't want to live in a world where there's no privacy and therefore no room for intellectual exploration and creativity." And Bjarne Stroup, his name is very difficult for me to pronounce. He's one of my personal heroes, the founder of C++, said, "People who think they know everything really annoy those of us who know we don't." I think that's true, right? He's a far smarter man than I am, and he seems to get annoyed quite frequently. So do we really need, let's be honest, do we really need another file sharing application? This is something I struggled with a year ago before I started writing Demon Saw. There's a lot out there, and every year there's a new file sharing app that comes out. Recently I found myself halfway around the world. I won't tell you what area of the world or what country, but it was far, far from home. And I found myself there for many, many months. And I realized that I had no good way of getting access to all the files that I had downloaded previously. I had no good way of sharing or accessing my content. And I felt a little vulnerable. And I thought, why is this the case? Well, I could have FTP'd it somewhere, or I could have uploaded it to the cloud, or I could have paid Dropbox or Amazon a shitload of money to host my content. But I realized I wasn't happy with the current state of file sharing. I wanted to share with my friends and my family, or 10,000 complete strangers. And I wanted to do it whenever I wanted on any device. I wanted access to all my content from anywhere in the world, and I wanted convenience and control. So why doesn't a solution for me already exist? I realized this is a problem that we could solve. I'd like to introduce you to Demon Saw. Demon Saw is a tool that allows me to share my files my way. In fact, just this morning, we made DemonSaw available to the public, demonsaw.com. If you go there, you can download it, have fun, do whatever you want. It's free. When I was stuck across the world, I realized that most file sharing networks, they really break down to 3 fundamental components. When you look at any file sharing network, BitTorrent, FTP, doesn't matter. They all come down to 3 fundamental components, and that is you have a client or multiple client nodes. And what these do is these either upload or download. They either share or acquire data. And then you have this type of node that serves as really a message propagator. What it does is it controls program flow. It makes sure that messages get sent where they need to. This can be torrent trackers, or this can be built into the client in the case of more direct applications like FTP. And then finally, you have what I call a server component, which is really responsible. It's the dumbest of the 3 components. All it does, it's like a tank. All it does is data gets sent through it. 99.99% of the bytes get sent through the server. All it does is propagate data. Most file sharing applications have combined these 3 components into 2 components. Either the client and the server are combined, or the router and the server are combined and the client is separate. DemonSaw is a completely new type of file sharing application. The architecture is based on a combination of network routing, web-based, and security patterns. But it's deceptively simple at its core. The magic behind DemonSaw is it keeps these 3 functions, these 3 different client, router, and server nodes separate. It doesn't try to combine them. And because of that, it's able to achieve an enhanced level of security and anonymity that we'll see shortly. So what I want to do now is I want to give you a quick, very, very brief demo of DemonSaw and just show you what it can do. It's just going to be a local demo, but it is going to be a live demo. There we go. A little patience here. Okay. I'll just talk you through a very, very basic scenario. What's going to happen here is a router. Here it's just a Windows-based router, but, all right, thank you. Let's see if I should. All right. Well, we're going to use our backup demo then, which is a static demo. Hopefully that will work. Okay. Sorry about that. There's always technical difficulties, live demos. I will be available after this in the cafe, and I will be glad to walk you through the live demo or answer any of your questions that you may have. So I always come prepared. Let's talk about the demo. Julian Assange also said nonconformity is the only real passion worth being ruled by. And Sean Parker, a very, very famous person, anyone know who Sean Parker is? Okay, exactly. Said, you can now be the master of your own destiny. What you're going to see here is you're going to see the client. Basically, there's 3 downloads that I've made available. There is a Windows-based router, which serves only as a message facilitator. All it does is it groups clients and it controls message flow, and that's it. There's the client, which you see here, and that's just going to share, search, browse, and transfer. And then you have a web-based server that I have available, which is a .NET web app that you can drop in any .NET web hosting provider, and all of your data will be sent through that. So for $3 or $4 a month, you can go to a hosting company and you can get something that supports .NET 4.5. In fact, fuck it, get 25 of them for $100 a month. Get 25 hosting environments for $100 a month, and you could basically be routing as much traffic as you want through it, because web hosting is so cheap these days. But the web server will allow the router to not have to handle large streams of data. So here in this example, we've searched for, I think, Daft Punk. For some reason, I want to listen to a new Daft Punk album this day. So all you do is you just type search, bang, instantaneously gives you the results. In the next window, you have a browse function. This allows you to navigate through any of the content in your secret group. Now, a secret group is going to be defined by an AES key that's going to be dynamically created by some sort of shared asset. In this version of DemonSaw, that shared asset is simply going to be an image. So let's say the front row and I'll have that picture of the Christmas party where things got a little crazy, right? All right? Things got a little crazy, we all had a good laugh, and then we all wanted to forget about that party. Well, let's use that image, and suddenly the 12, 13, 14 of us are in a group that nobody else can get to. And anything that we share will only be available to us in the group. But even through using the client, we're not going to know that I'm downloading from you, or you're downloading from me, or you have X, Y, and Z files available. But we are going to isolate ourselves to a specific group simply by this shared image from which our dynamic AES keys are going to be created. We'll be able to browse each other's content. And by the way, the names of the clients here are really irrelevant. You can make them whatever you want. Server and workstation seem to work for me. You can transfer and download stuff and see your status, very Napster-like. And here, you can share content. So I can choose what folders that I want to share. And this is a little browse window where I can get access to my content. And right here, you see the little image of the little demon guy. That is the image from which the AES keys will be created. So if you want to deny somebody access to your group, this is why security is almost unnecessary and insignificant for DemonSaw. All I do is I change my image and nobody gets access to my shit. That's all I have to do. So let's say one of our friends that we don't like to hang out with found that image, all right? And he suddenly wants to transfer all of our Daft Punk. And for some reason I don't like him. We just change our image. There's no need to revoke security access, or we change an image every day. It's something different. The lack of an image will default to the global or the default group, which is basically what BitTorrent does now. So if I choose not to have an image, it defaults to nothing. Oops. All right. Now, sorry about the technical difficulties. Now, how does DemonSaw address all these problems that we talked about with file sharing, right? First of all, it's secure. There's no peer-to-peer. There's no IP addresses that are revealed. Nobody can know what you're downloading. Nobody can even know what you're uploading. Then there's no centralized servers. The routers and the servers that we talked about can be dynamic and shift as much as they want. In fact, I don't have my phone on me, but now I do. We're right now working on an Android port of DemonSaw that will bring the client and the router to your phone. So what that means is I'll be able to host a private file sharing network on my phone, and all the data that gets transferred can be sent through hundreds or thousands of different servers all around the world. They can be in countries that don't discriminate against data sharing rules or data sharing in general. But I can control my own private file sharing network from my phone. That's what we're working on right now on Android. And I can download stuff from my phone. And we'll also be working on Chromecast and possibly Plex plugins. So you can download stuff, and 2-3% that it's done, you can stream it to your TV. Anywhere in the world, have access to any stuff. So it's not just local like Plex or DLNA or XBMC, but you'll be able to do this from your phone. We all have old phones, Android or otherwise, that are sitting around, right? They're doing nothing. Plug them in, make them routers. Take them with you, have them access wireless networks, and suddenly you have a mobile router that is your file sharing network, that nobody knows what you're doing. DemonSaw is encrypted. Everything is encrypted. There's multiple layers of encryption. We leverage encryption standards. You could theoretically rotate encryption keys and algorithms at will. That's something we can easily add if the need's out there. There's varying encryption types and algorithms. We use Diffie-Hellman, we use AES, mutating, automatic, isolated, data-driven, and stateless algorithms. There's varying encryption techniques. Messages and data are encrypted separately. So if somebody sniffs your network and they happen to get access to one of the message packets, and they happen to know the shared Diffie-Hellman key by some act of God, and they happen to decrypt that message packet, they won't even know what you're trying to do. They won't know what packet that belongs to, whether it's uploading or downloading a file. They'll have no idea what type of file you're sharing, or even if you're sharing a TurboTax document from 2003. They'll have no idea. In order to know that, they have to completely compromise the entire end-to-end chain, which is what we saw with modular security. And of course, authentication and authorization is all done via keys. DemonSaw is anonymous. There's no logging, no registration, no data retention, no loss of control. In fact, I'll even go one step further. It's free and there's no ads. You can use it however you will. There's no callback to demonsaw.com. I don't even know you're using it. I don't even care you're using it. A year ago, I started on this journey to write this to meet my needs, and I want to share it with everybody because I thought maybe other people share my need. It's yours to use however you want. You can set up a sniffer and you can verify that I'm not sending any data back to demonsaw.com. It's modular. There's a separation of messages and content. We're unable to deduce the type of content exchange. This, of course, is the need-to-know basis. It's simple. You saw the interface. It's share, search, browse, download, and upload. And that's it. I'm sure the Android and the iOS versions will be even simpler once we've created. Use it at home, work, or while traveling. It will go right through most firewalls because it's standard HTTP. Nobody will even know what you're doing, which is great because I didn't really think about the security ramifications of this, but if you set up a DemonSaw client and shared your C drive, yes, you could transfer your entire work computer from home. I've not tried this. I do enjoy my day job and the paychecks that come as a result of it, but that is theoretically possible. It'll punch right through firewalls and it'll go right through proxies. As long as HTTP can get through, this shit can get through. It's everywhere. Windows, Linux, Mac, Android, and iOS, and the web. Right now, we just released the Windows versions of the router and the client, and a Windows web application-based version of the server. Now, the router will do server functionality. The router is a server as well. But if you specify additional servers, like the web server component, it will override that and allow the router only to do message propagation. We're working on the Android version. It's written in C# right now, but we're porting it to C++ so that we can roll it across all these platforms. So it's just a matter of time before it gets on Linux, gets on Mac, gets on iOS, and you should see something. Hopefully in the next 3 months we'll launch the Android version, fingers crossed. It's based on design patterns. I'm a game programmer. It's my professional job. And in game programming, we use what's called the entity component system. And what this does is this favors composition over inheritance. And it makes adding new code and expanding the system extremely easy. So in terms of faster and more flexible features and maintenance, we'll be able to roll out these features fast because it's based on the entity component system. DemonSaw is silent and unseen. We leverage standards, we avoid suspicion, and we remain undetectable. It's flexible and adaptive. As we said before, share files just with yourself, share them with your family and friends, or share it with 10,000 people. 1 million file sharing networks. And excuse me. And finally, if you're curious what the architecture looks like, here's a picture of a very, very simple DemonSaw network. The router is performing message propagation and data propagation services. There's 4 clients in this example. They don't have to be all different devices, but here's a very, very simple way that you can share your content just with yourself or with 3 other people. There's a UPnP functionality in the client or in the router, and it will just open up the ports appropriately in your routers. If you just have stuff and you just want to get to it from work, this is a great way to do it and not trust Dropbox or the cloud. And since it's your shit on your devices, it's free. This is a slightly more complicated design, which I think is going to be probably the majority of use. This is a friends and family model. Here you have a router that just does message propagation in the center. Very, very lightweight. This can be on a phone, or right now this can be on an old Windows box that you have sitting around doing nothing. You have a bunch of clients that can be anywhere. And you have some servers here, one a web server and one a Windows server that does the data propagation services. So when files are uploaded or downloaded, they're sent through the servers. And the router is a very, very lightweight. And finally, a much more complicated network topology of multiple routers that are completely isolated with multiple servers and multiple different groups that all have different AES keys because they have a different shared secret. The green groups all have the same shared secret, the red groups have a different one, and the purple groups have their own. We're currently working on session propagation technology, which would allow any routers that opt in to be able to propagate the sessions of people that are logged in, which means that you could theoretically log into any router and be able to access anybody else. This is something that we're working on right now. We haven't thoroughly tested it. We haven't really vetted some of the security concerns with it, but it's something that's in the works. I think it's kind of a cool idea. And in summary, Albert Einstein said, "Only a life lived for others is a life worthwhile." I created Demon Saw as a labor of love to meet a personal need. I want to share it with you because I think it met my need, and if it meets your need as well, then I encourage you, download it, use it, let me know whether you like it or not. If you have feature ideas, please email me. And Steve Jobs said, and one more thing, changing the world, our potential is unbound. We possess a tremendous amount of talent, we're good at what we do, and we enjoy what we're good at. We can create something new and beautiful that can change the world, and we can do it together. Demon Saw is a tool that deviates from the insecure models of file sharing. It's a new way to share our content without fear. It's secure, it's anonymous, it's free, and it's everywhere. My name is Eijah, and thank you very much. You can contact me here and Twitter and the website. Thank you.
Hey, Eijah. Eijah.
Yes.
I have one question for you real quick.
Oh, yes.
Can you explain how it is that you're tunneling the encrypted transportation over HTTP?
We're almost out of time, but I'll take a quick stab at it, and if you want more information, I'll be at the cafe afterwards as long as you guys need to meet or chat. Basically what we're doing is we're using standard HTTP, and so we're adhering to the HTTP protocols, and the data appears to look just like HTTP. So it's basically, if your firewall is set to allow HTTP content via port 80 or 443, then this will get sent. But because there's no direct connection coming into your network, there's no issues with firewalls blocking incoming transmissions because everything is designed from an inside-out perspective. So if that doesn't answer your question, I'll be glad to go in more detail.
Do you have the protocol spec published someplace?
I don't, but email me or follow me on Twitter and we'll definitely start the conversation, or I'll be glad to talk about it in more detail. As well as open source, I've gotten questions about that. Honestly, I haven't had time with development to even think about open sourcing it, but it's something that I'll definitely think about, and if you have some thoughts about it, I'd love to hear from you guys. So, thank you again.